Dementia is one of the biggest challenges to health authorities around the world. Put simply, it's one of the greatest challenges of our time. The way in which we aim to identify Alzheimer's disease in its earliest stages is by undertaking two kinds of tests. The first test is a test of spatial memory, because spatial memory is a function particularly controlled by a part of the brain known as the hippocampus, an area of the brain that is very early on affected in Alzheimer's disease, so the test of hippocampal function might allow us to detect Alzheimer's in its earliest stages. The second test that we do is something known as a functional MRI scan. Those individuals with early Alzheimer's disease may have early changes in their brain function that we can detect on functional MRI. So those are the four choices. Have a look at those. BSMS is ideally suited to undertaking dementia research because Sussex has a higher proportion than the national average of people over the age of 60. By doing such research locally, it allows those individuals within Sussex who are getting older, who may have very mild dementia, to take part in research and have access to state-of-the-art imaging and research tools that ordinarily wouldn't be available except in large research centres around the world.
Developing a new medical school means developing an interesting and effective teaching programme. But that has to be accompanied by a vibrant and successful research culture as well. Even experienced doctors sometimes have difficulty in explaining the complexities of modern treatment. We're involved with designing effective educational interventions to help healthcare professionals with communication. Countries throughout the world have facilitators running some of our programs.
My research is about inflammatory signals and intracellular signals in tissue injury. When you have an infection or injury, including ischemic injury, like in stroke or myocardial infarction, some cells of the immune system will release inflammatory signals that we call inflammatory cytokines. They will go and hit other cells, and other cells will become inflammatory cells. And this is how the injury propagates. We found that some cells can produce what we call tissue protective signals. These tissue protective signals will promote the differentiation and the growth of neurons. We think that if we identify signals that promote regeneration and repair of the injured tissue, you could identify basically new drugs to promote repair, very much along the same line as stem cell therapy, but in a way that we believe would be probably cheaper and more practical.
The main research that we're doing in the lab is looking at rheumatoid arthritis and chronic inflammatory conditions. Some of the best therapies that are available for rheumatoid arthritis are incredibly expensive, which really limits their distribution. So what we're hoping to do is have a more targeted therapy which would hopefully have less side effects and also be much cheaper to produce. I absolutely love being down here because there's a real concentration of people here working on inflammation, but they're not working on the same diseases as me. So they have other techniques and expertise and also other ideas which they contribute to the work that I'm doing, which really helps you to broaden your horizons. So it makes working here even better.